Hey everybody, so today we are going to learn another multiplication strategy, and just like partial products, this is an approach that you can take to solve problems, or that you can use. So this one is called ratio tables, so probably familiar from other years, so hopefully it's a nice review. It is very useful, so it's important to master this now, and maybe you'll pick up some different tips along the way as well. So here we go. So ratio tables. Ratio tables a lot of times look like this, kind of sideways like this. Sometimes they also go up and down, and I can show you one of those later as well. Okay, and we can use them to help solve multiplication problems. So let's go ahead and do a problem up here. So let me write it down. How about, let's do 23 times, I don't know, how about 14? So not a basic fact, not something that we should memorize, okay? But we can use this to help. So when I first learned about ratio tables, I was introduced to a term called the core 4. Okay, the core 4. And I'm going to explain to you what the core 4 means. Okay, so this is really 23 groups of 14, right? So 23 groups of 14. So sometimes I like to write that to remind myself. 23 groups of 14. So the core 4 says that we can start with the numbers. Let me write it in a different color so it stands out. We can start with the numbers 1, so we're going to find out what one group is, 2, 4, and 10. So if you start with these numbers, it's recommended because then with this you can build on anything and solve anything. So until you become super proficient in which you can pick your numbers, for right now I want students starting with the core 4, okay? And I'm going to demonstrate that now. So this is 23 groups of 14 that we want to solve for. First, we need to know what just one group of 14 is, okay? And I kind of just said it. One group of 14 is 14, right? So what's two groups of 14, and how can I find that? Well, if you look, how do you get from 1 to 2? You double it, right? Or multiply it by 2. Whatever you do to the top of a ratio table, you do to the bottom. So in order to get from 1 to 2, I simply double. So in order to get from 14 to this space, I can just follow that rule and double. But also, if you think about it, one group of 14 is 14, so two groups must be double that. And we can kind of have workspace. So a lot of times when I use ratio tables, I know I'm going to need some workspace on the side. So two groups of 14, I've got to double 14. So 14 times 2. 2 times 4 is 8. 2 times 1 is 2. So I get 28. Okay, so now let's look at our ratio table. One group is 14. Two groups is 28. How do we find out what 4 groups is? Look at your ratio table. What if I take 2 and I double it again? That would work because 2 doubled gets me that 4. Well, 28, what would I do to get to this blank? Follow the same thing. So 2 times 2, so this must be 28, and follow that same rule, times 2. And again, use your workspace, 28 times 2. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. So I've got 56. Let me write it in the right color. 56. Okay, so let's review. We need 23 groups of this number. So far, one group is 14, two groups is 28, four groups is 56. You might be thinking right now, oh my gosh, this is slow. Once you get these core four, I promise it goes a lot quicker. Are there quicker strategies? Yeah, like standard algorithm is quicker, but this is a different approach, and it kind of helps you see. When I think of ratio tables, I think of building. You're slowly building, okay? So now I want to see how many 10 groups of 14 gets me. Well, I can't double the way I've been doubling because 4 doubled isn't 10, okay? So I have to work with this a little bit and think about how can I go here? Oh, what if I start way back here at 1, make a huge leap? What if I do 1 times 10? Well, 1 times 10 got me 10. Now let's make that same leap. Except 14, what am I going to be doing to that 14? The same thing I did on the top. So I did 1 times 10 to get here, so I'm going to do 14 times 10 to get here. Let's use our workspace. Now, remembering tricks with zeros with multiplying. So I can do 14 times 1 is 14 and tag that 0 in the end. So I get 140. Okay, so now we have officially solved the core 4. And again, by the core 4, I mean we found out what one group is, we found out what 2 groups are, we found out how many 4 groups are, and how many 10 groups are. So the reason the core 4 is suggested is because now that you know that, you can easily solve for anything. So we need to solve how many 23 groups are. Now I have to start to think about where I want to go next because it's unknown. See how there's blanks here? It's kind of like up to the world is your oyster. You pick. So let's think. How can I get close to 23 groups? Well, what if I got to 20 groups first? Because I'm seeing right now, if I double 10, I can easily get to 20. And that means I just double 140. So 140 doubled. And some of you could do this mentally, is 280. So we are getting super close now because now I see 20 groups of 14 is 280. I only need 23 groups. Now this gets a little tricky, and I'm going to take my time explaining it. If 20 groups is 280, I want you to look at the table right now. I've got 20 groups is 280. Do I have other information that can get me to 23? So just think about it. I already know what 20 groups are. 3 more groups. If I could just figure out how many 3 more groups are. Hint, look down here. 20 groups is 280. Well, what if I did 20 plus 2 more groups plus 1 more group? Because look, 20, 22, 23 groups. So how much is 23 groups? Well, if I add up 1 group plus 2 group, that gets me how many 3 groups are. And this is how many 20 groups are. So 23 would be all of these together. So let's look at that. 280 is 20 groups, plus 28 is 2 more groups, plus 14 is another group, so I'm adding them all up. 8, 9, 10, 11, 12. 8, 9, 10, 11, 12. And 2 plus 1 is 3. So, we just found out that 23 groups of 14 is 322. And I want to point out one more time, because it can be a little tricky, we really found out what 20 groups were, and then we had what 2 groups were, and what 1 group was, and we added it. 20 plus 2 plus 1 gets us 23. I want to also suggest that we always label. So I think it was super helpful for me that I labeled groups of 14. So I knew what my ratio table was saying, okay? So some of you, if you know the standard algorithm, might also find comfort. You know, when I was a student, I would say, okay, this is great. I want to practice ratio tables, but I would like to check in the end 23 times 14 and go ahead and use a different strategy, maybe standard algorithm like I'm showing you right now, or maybe even partial products from the other day, and practice it. Make sure that your answers match. So 4 times 3 is 12, 4 times 2 is 8, plus 1 is 9. Now I need my placeholder 0 so that I can call that a 1 and not a 10. So 1 times 3 is 3, and 1 times 2 is 2. I've got partial product, and let's add it up. 2, 9, 10, 11, and 12. 2 plus 1 is 3. So I never think it's a bad idea to check your work using a different strategy. And that lets us practice a whole variety, okay? So with my ratio table, if you're feeling a little fuzzy about it, try it and then check it with a different strategy to see my answers matched. Okay, so I must have done the ratio table correctly. Okay, we are going to do some more practice together, so you don't have to be an expert yet. And hopefully this can be a tool that you throw in your math toolkit and help to solve some of these difficult problems.